Okay, so number 7, we switch the signs, so it's x minus 3 and x plus 4. And then on number 8, if it's calculator based, it can be left like this. So if it's calculator based, then I would make this my y1. This would be my y1. Oh my gosh, color that you can see. Y1 would equal that, and y2 would equal that with your change of base, because notice the bases are different. And then you would look to see where they intersect, okay? If it's not calculator based, then the bases would be the same. So if it's not calculator based, it might just say log of x plus 2 is less than log of x plus 2. Well, it would be also something different, so that you could, it may be like a 3x plus 2, so that you could eliminate your logs and you could solve it from there. So let's just say if it was this kind of question, I would eliminate the logs. I'd get x plus 2 is less than 3x plus 2. I'd subtract the x. 2 would be less than 2x plus 2. Subtract the 2. And I'd end up with, divide by 2. And I'd end up with x is greater than 0. And then in that case, even my lower bound, like, so then I'd also have to check for a lower bound. This is technically a lower bound, whereas if it was less than, it would be different. But if it said 0, then I would be looking at that in terms of my graphed solutions. And then up here, this would have to be greater than 0, and this would have to be greater than 0. So x would have to be greater than negative 2, and x would have to be greater than negative 2/3, which by making it 0, it already is. So it would be 0 to positive infinity. If it was a less than sign, or if it was the reverse, let's say it said log of x plus 2 was greater than log of 3x plus 2, I'd end up with x is less than 0. Then I would definitely have to go back and check to make sure that the lower bound is here by saying whatever's next to the log can't be 0 and it can't be negative, so it has to be greater than 0. And I'd get x has to be greater than negative 2 and x has to be greater than negative 2/3. So on the number line, I'm saying it has to be less than 0, but I'm also saying it has to be greater than negative 2 and greater than negative 2/3. And I need it so that everything, oh, I have written a whole bunch more. Let's see if it catches up. It needs to be where everything overlaps. So in that example, my answer would be negative 2/3 to 0 with a parentheses on both of them. So I would say you need to be prepared for like all 3 of those kinds of scenarios. One in which it's a greater than, so there is no lower bound. One in which you have to check for your lower bound. And one in which you have to use your graphing utility to look for where they cross. So all of those scenarios are like, could be on the test. For 7, there's more than one log on one side, right? So you have to condense it first. So it would be log base 3 of x minus 3 times 2, because addition becomes multiplication, is less than or equal to log base 3 of x plus 4. So then because they both have a log with the same base on either side of the equal sign, you can literally ignore it. And I'd get 2, I'm going to distribute this. 2x minus 6 is less than or equal to x plus 4. Then I would subtract the x. X minus 6 is less than or equal to 4. Add the 6. And x has to be less than or equal to 10. But again, there's a lot, and be very careful because that's going to be an answer choice, right? You're going to go look at your answer choices and it's going to say negative infinity to 10 and you're going to get excited and you're going to circle it and it's wrong. You have to check all the ones that have logs. So if it were me, like maybe skim through your test and anytime you're solving a log, whether it's an inequality or an equal sign, I would put a little star next to it or something to remind you to check for the lower bound answers or to check to eliminate answers. In this case, this has to be, so from here, this has to be greater than 0 and this has to be greater than 0. So x has to be greater than 3 and x has to be greater than negative 4. And we look for the more narrowed one, right? So if those were both on a number line, I'd have negative 4 and I'd have had 3. It has to be greater than negative 4 and it also has to be greater than 3, which means from 3 to where I stopped up here, which was 10. 10's the upper bound. 3 to 10 would be the answer on it. Any other So on this kind of question, notice it says, what's a log regression? Like it specifically tells you to run the log regression. But on the last one, I didn't. So this time, do a exponential regression for the first part. Then you can skip the taking the log of both sides because you'll get to use your calculator on that part. So then I would go to complete the table to find a log. And then this time, make sure you notice that it says find a linear regression. So those might be two different questions. Those might be the same question with multiple parts. But in both cases, you'll know what kind of regression you need to run. Just be really careful.